Good morning, students. So we completed 3 lessons. Now in this video, I'm going to start about the 4th lesson. Students, small request. I got information that you are not watching videos and even you are not completing your classworks. Please complete your works and be update. uh, just to spend daily 1 hour time and use then write your works, complete your works and listen videos. Okay, now coming to our topic. Before going to start our lesson, just introduction. In our daily life we use different materials. For different purpose we are using different materials. So all these materials, in this material some are acids, some are bases, and some are salts, some are fibers are there, and you discussed about the types of soil. So many materials were there. In all the material, these materials are mainly classified into 3 types. They are metals and non-metals, and one more is semi-metals. Mainly these materials are classified into 2 types, metals and non-metals, and one more classification is there, that is semi-metals or metalloids. So today I'm going to start, the topic is our lesson 4. Lesson 4 is metals and non-metals. So what is our lesson 4? Metals and non-metals. And these materials are how many types? 3 types. Mainly 2 types, and one more category is there, that is semi-metal. But about that it was not given in our textbook. So we'll discuss about metals and non-metals. But I will explain about the information about the semi-metals also. Okay, children. Now coming to, about the metals. So these metals, what can you give examples of metals? Yes, iron, gold, silver, copper, and copper, iron, silver, and here I wrote, you see, gold, silver, aluminum, copper, iron. So many are there. These are some of the examples. So these gold and silver you can use as ornament purpose, and aluminum is used for the, even in the cookers, rice cookers, that vessels, in the vessels, and uh, mainly tools. Copper for the wiring purpose, copper vessels are there, copper bottles are there, and iron is the construction of the bridges, railings, and in the slabs, iron chairs are there, iron tools are there. So these are all the metals we are using in our daily life, and these are the some of the examples of metals. And these metals are very hard. When you touch, you cannot break those metals. They're very hard. Now coming to the semi-metals. I said you 3 types. So semi-metals means, first we'll discuss about the non-metal, then after I will come to the semi-metal. Non-metals means, first, what are the examples of these non-metals? If you take coal, gunpowder, sulfur, iodine, and magnesium, all these are all comes under non-metals. So metals, they exist in the solid form, and these non-metals, they may exist in 3 forms: solid form, liquid form, and gaseous form. And this sulfur, carbon, all these are used. Some are used in the preparation of ointment, some are iodine is used in the preparation of the tincture, and sulfur is used in the preparation of the gunpowder, magnesium and sulfur, these two are used in the fireworks. So like this we can use non-metals in our daily life. Coming to the semi-metals. What are semi-metals? Semi-metals means that materials, they are not metals and they are not non-metal. They are in between the metal properties of metals and non-metal. Means these materials are not considered as a metal, but at the same time it does not consider as a non-metal also. So these materials are having the properties of both metal and non-metals. Such materials will call it as semi-metals or metalloids. What are the examples of these semi-metals? Boron, silicon, antimony, arsenic. These are the few I wrote. And what are the uses of these semi-metals in electronics? Suppose if you take the computer, TV, cell phone, in all these electronics, that in that what we'll call that current electronics, they're using these semi-metals mainly. Okay, now in the circuits they're using this semi-metals. Now suppose if a material is given, suppose a material is given, how can you identify the given material is a metal or a non-metal? How can you say that? By seeing we can't say. So gold means, suppose a gold piece is given, so can you say is it real gold or that? You have to do some tests. So you have to go some property, you have to find out some properties. Due to that you can find out whether the given substance is a gold or something. When a material is given, how can you identify that whether it is a metal or a non-metal? So for that we have to learn more about metals. So we have to learn about the properties of metals. Properties means we have the physical properties and chemical properties. And physical properties mean that I'm going to explain in this video the physical properties of metals and non-metals. Okay. Generally we have the two properties, physical properties and chemical properties. Physical properties means just the external properties. External properties means whether the given substance is the size, shape, nature, height. Like how we can find out, suppose a student is there, what is his height, color, then he fat or thin, like that we can find out by seeing the outline. So that all comes under physical properties. Chemical properties means how the child, how that student is behaving with the other, how he is talking with the teachers, how he is how sorry, what is his name, how he is behaving at the house, how he is interacting with others. That all comes under the chemical properties. Now in this now I'll start with the physical properties of metals and non-metals. In that, the first property is luster. The first property is luster. Here luster means what? Luster means the materials are having the shiny surface and a smooth surface. And when it is having the shiny and smooth surface, when light falls on that surfaces, they should reflect the light. Such materials are known as that property is known as lustrous property. Here, here I wrote here, you see. Lustrous means the materials which show brightness on the surface and reflect the light are called lustrous. For example, you collect the different metals. Iron, copper, steel. Steel does not comes under that is a different category. I will explain later at the end of this video, at the end of this lesson. So you take the different metals, and suppose if you take the iron, they're not smooth. So you take one sandpaper and make it rub with that sandpaper, then make it smooth. Then you observe when light falls on that, where from that surfaces whether the substance materials are reflecting the light or not. So most of the metals, they reflect the light. Most of the metals, they reflect the light. So all the metals, they're having the property of lustrous. Coming to the non-metals, leave about the semi-metals. You don't have about the semi-metals. Okay, just I wrote it. Now coming to the non-metals. So these non-metals, mainly the metals are exist in the solid form, and non-metals that exist either in the solid form, liquid form, or gaseous form. So these non-metals, uh, they're in exist in the three forms, so they don't have they're not exhibiting the reflection of light. Means when light falls on that, these substances will not reflect the light, so they are non-lustrous. Non-metals are always non-lustrous. So for this, you have to do one small activity. You collect the different materials and find out so which of the materials are reflecting and which of the materials are non. Suppose you take a coal, when light falls on the coal, from that coal light reflects. No, you take some powder, sulfur powder or something powder, magnesium powder, like you take, when light falls on that, from that powder light reflects. No, it is not possible. So almost all the non-metals, they are the non-lustrous. Now another property, what is that another property? Sonority. Sonority means what? Just you drop any object means that materials contains metals and non-metals. So just you drop any material. Suppose if you drop a material like any vessel which is made up of metal, just you drop it and find out it produces a sound. If you drop any object, it produces a sound. So you just observe the sound, the object, the materials which are producing the vibrating sound, ringing sound, then such objects, that that property is known as sonority. So all the metals, they're having this, all the metals are sonorous or otherwise. Means when you drop any metal, it produces vibrating sounds or the ringing sound. Not vibrating sound, just they produce the ringing sound. So that metals, almost all the metals, they have this sonorous property. Now you take the suppose this is a non-metal. If I drop this, it produces sound, but this sound is not ringing sound, like ting, like cannot continue that. Just it produce the sound tap and it stops. So metals means they produce the sounds of the ringing sound. So materials which produce ringing sound are called as sonorities. Means the all the metals are sonorous. Non-metals, if you drop the powder or the chalk or the wood is not comes under metal, so comes under non-metal. So these are all they're not sonorous. See, in the first property, lustrous, having the smooth and brightening surface, I said, means when the light falls on that, it should reflect. For example, if you take the mirror, it has very smooth surface. When light falls on that, it reflects the light also. So is why then mirror is not coming to the metal? Means we cannot find out by the single property of the lustrous whether the given material is a metal or non-metal. We have to find out all the properties, then we can find out the given material is a metal or non-metal. So by the single property that mirror is having the smooth surface and it reflects the light, by this lustrous property we cannot say that that mirror is a metal. Okay, we have to find out all the properties. If all the properties are followed by such material, then it becomes a metal. Like that we have to find out. Now coming to the sonority. Okay, see mercury that we are using in the thermometers. Mercury is all the metals exist in the solid form, but except one metal, that is mercury. All you know about this mercury that we use in the thermometers. So this exists in the liquid form. except the mercury. Remaining all the metals exist in the solid form and they are sonorous except the mercury. Next, coming to the non-metals, they are not sonorous. They are not sonorous. That's why we have one question in our textbook. While preparing that bells, they're using the metal bells only. That's when you just ring the bell, it produces the continuous ringing sound. You can hear that sound. Why we can't made that bells with the wood or some plastic or some other materials? Because they too produce sound and that the sounds are not louder and they cannot produce the ringing sound. That's why we are not using the bells for non-metals. We are not using non-metals. We are using only the metals only. Next, one more property is malleability. What is that? Malleability. What is malleability? Malleability is nothing but see, if you see that, have you observed about goldsmith? He's not goldsmith. One minute. Have you noticed that a thin silver foil is used in the sweets for the decoration of the sweets, and at the same time aluminum foil is used for the package of food? That did you observe? Yes, you may observe that. So how it possible that the metals they are making into like sheets? The metals either in the sweets, decoration of the sweets or the packing of the foods, they're using the aluminum, either aluminum some other materials. So how it possible they are making that metals into the sheets, thin sheets? So the metals are making into thin sheets. That property is known as malleability. Is known as malleability. And I'll give one more example that wait, I will like that blacksmith, he beats blacksmith, he beats a hot iron piece into the sheet by hitting several times, and he is making that sheet. Suppose instead of that metal, if you take a non-metal like a clay or uh, wood or something, by using this property, can you make it into the sheets? No, it is not possible. Only metals you can make it into the sheets, either thin or thick sheets. So this property is known as malleability. Malleability means the materials which can be flattened into thin sheets are called malleability. So metals are having the malleable property. Non-metals, that carbon, coal, you take it and heat it several times, can you make it? No, it becomes powder, so you cannot make it into sheets. So first you collect the different type of materials. In that it contains metals and non-metals, and you beat it several times, which we can make it into the sheet and which are making into the powder. You note it in one tabular form. Okay, see in that, here I wrote here, you see, observing the change, flat ends, which you make it into the flat, only the metals iron, gold, silver and copper, and breaks and converts into the powder only the non-metals magnesium, sulfur, carbon and iodine. Next, one more property. What is that one more property? That is ductility. So what is ductility? Ductility is nothing but, for example, in the wiring purpose, for the wiring purpose we are using the wires for the conduction of electricity current. So all these wires are made up of metals only. We are using copper wires, and even outside we are using aluminum wires, iron wires, we have that wires. So the materials which are making into wires is known as ductility. The property of drawing a material into make fine wires is known as ductility. By using non-metals, is it possible? No, it is not possible. So non-metals are non-ductility, means they don't have the ductility. You cannot make it into the wires. You cannot make it into the wires. Next, so we discussed how many properties now? Four properties. Once I will repeat it. Metals are having the lustrous, sonority, malleability, and ductility. Two more properties are there. They are the electrical conductivity. What is that? Electrical conductivity. All of you know that you take one cell and you take a small conducting wires and you take a small LED bulb or some bulb, small bulb, you take it and give connection and observe that the bulb is glowing or not. Definitely when the cell is charged, then obviously the bulb is glowing. Now here I drew this circuit. Take a cell, these are the conducting wires and this is the bulb, and in between these wires you take one iron nail. You take one iron nail and give connection like this and complete the circuit. And when the circuit is completed, you observe the bulb is glowing or not. Obviously the bulb glows. How it possible? Because the current passes through the nail, means the metals are allowing to pass the current through them. So that's why we'll call it as metals are good conductors of electricity. The metals are good conductors. Instead of this nail, you can take the different metals. Almost all the metals, they conduct electricity. Copper, aluminum, iron. You take any metal, all the metals conduct electricity. Each time it bulb glows. Non-metals, instead of this nail you take some powders or some wood or something you take, then bulb glows? No, bulb does not. Means non-metals, they don't have the conductivity of electrical conductivity. They are the bad conductors. They are the bad conductors. Now last property is heat conduction. Heat conduction means, suppose you take one metal vessel, you take steel, not steel, either the iron or copper, you take some one vessel and just place it on the stove and heat it. After few minutes, can you hold it, the vessel, without that tongs or any cloth? No. Why? Because it is very hot. When you touch it, you may get burn. Not you may get, definitely you cannot hold it also. That much hot. Why? Because the metals absorbs heat. Metals absorbs heat, and we have one experiment about this heat conductivity. So what is that? You take one stand, and to this stand just you take one rod, any metal rod. So for example, you take the iron rod, and to this rod you take this iron rod. With the help of the melted wax, you take the nails. With the help of the melted wax, and fix the nails to this iron rod like this. Like this you fix it, all these nails, and this rod you have to fix to this stand, and take any what is that, uh, flame, either candle or bunsen burner, anything you take it, and heating start heating that metal rod. When you heat it, what happens? Just you place it this at here, this lamp, this now slowly when it is burning, the heat is passing through this iron rod, and you observe that. When you observe, after few seconds, the iron nails are falling one by one by one. Which side of the nails are falling, this side or this side? Just you observe that. Generally from this side the nails are the nails are falling one by one, one by one, one by one, one by one. Actually you kept the this flame here at one side, you did not keep this side. Even though after some time all the nails fell down. Why? Because here whatever the heat is absorbed by this rod, from this rod the heat is passed throughout this rod from one place to the other. From this you can say that, and the heat is transferred uniformly, and because of that reason all the nails fell down. All the nails fell down. So from this you can say that all the metals are good conductors of heat, for heat conduction, good conductors of heat. Instead of this, you take the coal or plastic or wood or something, and you observe whether the nails are falling or not. So you cannot observe that nails are falling like this. So from this activity we can say that all the metals are good conductors and non-metals are bad conductors of heat. We'll discuss more about the chemical properties in another video.